Hi everyone, this is Professor H. Rahman from Agricultural and Food Engineering Department from IIT Kharagpur. I welcome you all to this NPTEL course on traction engineering. Today I will try to cover rolling resistance of a pneumatic wheel. As we know that wheel and truck, they are the two traction devices which are commonly used in a tractor. So that's why we are considering wheel, and in subsequent class we will consider how to find out rolling resistance of a truck. Now here the concept will be how to find out rolling resistance of a pneumatic wheel. So when you consider wheel, rolling resistance will be because of three things. One is due to flexing of tire, the other one is due to soil compaction, and the rolling resistance could be due to bulldozing. So either all three are present or any one of them will be present. So both will that will contribute towards the rolling resistance. So when the wheel runs on a hard surface, the first component, that is your tire flexing, will be the main component for rolling resistance. So for this reason, the inflation pressure in wheels for on-road vehicles are kept relatively high. When the tire runs on a soft soil or a yielding surface, the last two components, that is your soil compaction and bulldozing, these are the two components that will contribute towards the rolling resistance. And compaction resistance decreases as inflation pressure decreases. Why? Because when you decrease the inflation pressure, the contact area is increased, so ground pressure is decreased, hence compaction resistance is decreased. So therefore, for off-road condition, the inflation pressure should be as low as possible. And coming to the bulldozing resistance, this is basically caused by soil being thrown up and carried along in front of the wheels, which will form a bow wave. So it increases rapidly with increase in width to diameter ratio. So wheels with lesser width to diameter should be used to prevent bulldozing. So this is the background of rolling resistance of a pneumatic wheel. Then in case of a pneumatic wheel, it behaves in two different modes during operation. The first mode is in rigid mode, the second mode is in elastic mode. Rigid mode means the rolling resistance, the tire will simply sink into the soil. It is not flattened. Okay, so if the ground is sufficiently soft and the sum of the inflation pressure Pi and the pressure which is produced by the stiffness of the carcass Pc is greater than the maximum pressure the terrain can support at the lowest point of the tire circumference, then the tire will remain round like a rigid wheel. So this is referred to as rigid mode of operation. That means Pi, inflation pressure, plus pressure which is exerted by the carcass due to carcass stiffness. If sum of these two is greater than the pressure which the terrain can support, then it behaves like in a rigid mode. If the terrain is firm and the tire inflation pressure is low, so what will happen? A portion of the tire will be flattened, which is indicated in this figure. If you look at the right corner, this one, the portion is flattened. This condition is referred as elastic mode of operation. So now we have to see first whether the wheel is in elastic mode or whether the wheel is in rigid mode. So if the tire behaves like a rigid rim, then you have to use the same Baker's equation what we have utilized in case of a rigid wheel. And the normal pressure at the lowest point of the tire is given by Pg will be equal to Kc by B plus K phi into Z0 raised to the power n. Now, if you substitute for Z0, just now we have derived for rigid wheel, so then it becomes Pg will be equal to Kc by B plus K phi raised to the power 1 upon 2n plus 1 into 3W by 3 minus n B into square root of D raised to the power 2n plus 2 by 2n plus 1. This pressure is now called critical pressure because this is the pressure which will be utilized to demarcate whether the wheel is in rigid mode of operation or whether the wheel is in elastic mode of operation. Now, that is denoted as P ground critical, ground pressure critical. If the sum of the inflation pressure Pi and the pressure which is produced by the stiffness of the carcass Pc is greater than ground pressure critical PGCR, then the tire will remain round like a rigid wheel and the rolling resistance will be equal to just like the rolling resistance of a rigid towed wheel. R is equal to 1 upon 3 minus n raised to the power 2n plus 2 by 2n plus 1 into n plus 1 into B raised to the power 1 upon 2n plus 1 into Kc by B plus K phi raised to the power 1 upon 2n plus 1 into 3W by square root of D raised to the power 2n plus 2 divided by 2n plus 1. So, the behavior will be similar to the behavior of a towed rigid wheel. That means the rolling resistance expression will be same. Now, when sum of the pressure Pi and Pc is lesser than ground critical pressure, then a portion of the tire circumference will be flattened and the contact pressure on the flat portion will be equal to Pi plus Pc. So, if contact pressure is Pi plus Pc, then the sinkage we can calculate Pi plus Pc by K raised to the power 1 upon n, and R we can calculate R will be equal to Bk Z0 raised to the power n plus 1 by n plus 1, just like in plate sinkage test, and finally the expression will be R is equal to Bk Z0 n plus 1 by n plus 1. Now, if I substitute this Z0, so Z0 will be P by K raised to the power 1 upon P is equal to Kz to the power Kz to the power n. So, for Z0 if I substitute, so P by K 1 upon n. If I substitute here and for P I have taken Pi plus Pc, now the equation becomes rolling resistance will be equal to B into Pi plus Pc raised to the power n plus 1 by n divided by n plus 1 into Kc by B plus K phi raised to the power 1 upon n. That means rolling resistance depends on what is the inflation pressure, it depends what is the pressure, stiffness of carcass, the pressure due to stiffness of carcass, then it depends on the section width of the tire and the cohesive modulus of sinkage Kc and the frictional modulus of sinkage K phi and exponent of sinkage n. So, average tire which will be average ground pressure of the tire that will be equal to the problem associated with this Pi plus Pc is it is difficult to measure Pc because it varies with load, it varies with type of tire, it varies with inflation pressure. So, what Baker have suggested is instead of Pi plus Pc, you can take ground pressure Pg. This ground pressure value is available from the tire manufacturer's data. So, it will be easier for us to calculate. So, if we are taking ground pressure, then the equation will be R will be equal to B into Pg ground pressure or Pgr raised to the power n plus 1 by n plus 1 Kc by B plus K phi raised to the power 1 upon n. And Z0 also you can similarly do. Instead of Pi plus Pc, I can write Pgr and divided by Kc by B plus K phi raised to the power 1 upon N. Now, how to find out average ground pressure? Is on a flat portion, the average ground pressure of the tire will be equal to the load carried by the tire divided by the corresponding ground contact area. If you know the ground contact area, or if you can find out the ground contact area, knowing the load, you can find out what will be the ground pressure. Load divided by area, that will give you the ground pressure, and then utilizing this equation, we can find out the rolling resistance. Now, if you look at this is the portion which is flattened, this is the portion which is remaining in chord shape. So, entire thing is entering into the soil. So, that means there is a flat portion, there is a curved portion, and the width we have taken as B, section width of the tire we have taken as B. Now, the contact patch, if you denote it as LT, for a wider tires like Terra tires, LT may be lesser than B because they are wider tires, so section width is greater than the contact patch. So, if that is the situation, then we have to take LT instead of B for all those equations which we have derived for sinkage or for rolling resistance. So, I have derived expression for LT. So, LT will be equal to 2 square root of d delta t. If delta t is if I take as this is the deflection delta t, so and this is the radius. So, this is your delta t and this is your radius r. Okay. So, now expression for LT will be, so LT will be this distance, this is your LT. So, LT will be equal to twice square root of delta into 2r minus delta, or diameter minus delta. Okay. So, you have to take either B or LT depending on which one is lesser. So, if LT is lesser, then you have to take the value of LT instead of B in Z0 as well as while calculating the rolling resistance. Along the flattened portion, the pressure will be equal to Pi plus Pc, which you have taken as ground pressure, and the W which is applied, that is carried by the wheel. So, that will be carried or supported by two components now. So, W will be equal to W1 plus W curve. That means a portion of weight will be supported by the flattened portion and the rest will be supported by the curved portion. Now, if I denote this flattened portion as AB and the curved portion as BC, so flattened portion W1 will be equal to, if B is the width and if you know the ground pressure, so into your L1. So, this is area into pressure, that will give you directly the value of W1. Now, for finding out the weight which is supported by the curved portion, we have to proceed in a similar way as you have done for the rigid wheel. That means, in the contact patch, the curved contact patch which is indicated as BC, the radial force acting will be dN. So, it will have a component dW, it will have a component dR. dR is related to your rolling resistance and dW will be related to the vertical load which is supported. Now, dW will be equal to, if I take a small element subtending angle d theta, which I have indicated in this. So, d So that area, whatever force is acting, so that is indicated as dW2, and dW2 will be equal to Bkz to the power n r cos theta d theta. Okay. Now x is equal to, x I have indicated here, x will be equal to r sin theta. Now dx by d theta will be equal to r cos theta. So dx will be r cos theta d theta. So dx will be r cos theta d theta. Now I substitute for this in here, so it becomes bkz to the power n dx. Now x square will be how much? This will be equal to r square minus r minus z0 plus delta minus z whole square. R minus z0 plus delta t minus z. Now if I simplify this one, so this will become twice r z0 plus delta t minus z minus z0 plus delta t minus z whole square. Now for silencing case, or for this expression with respect to the diameter is very low, so you can neglect this. So we can approximate as x square will be equal to twice r z0 plus delta t minus z. Okay. Now x will be how much? Square root of 2r z0 plus delta t minus j. Now if I differentiate this expression, so what I get is 2x into dx will be equal to minus 2r into dz. Now substitute for dx will be equal to minus 2r by 2x into dz. So 2 will cancel out. Now substitute for x, so it becomes r by twice r z0 plus delta t minus z into dz minus, this is square root. So now I substitute for dx in this expression here, so it becomes b kz to the power n, and there will be minus sign, r by twice r z0 plus del t minus z dz. This is square root. Okay. Next is, if I assume that t is equal to z0 plus del t minus z, then dt by dz will be equal to minus 1, or dt is equal to minus z. So now I substitute for minus dz as dt, so I can remove this minus sign. So this becomes b kz to the power n r dt. Okay. So dwt will be now finally I can write as, if this is clear, then I can directly write as dw2 will be equal to square root of r upon 2 into bk into z0 minus t minus delta raised to the power n by square root of t into dt. Now this is the expression. Now this term can be expanded binomially and only keeping the first two terms and neglecting the other terms. So this can be finally written as bkr by 2. This has to be integrated from delta t to z0 plus delta t. So z0 n into t raised to the power half minus n z0 n minus 1 into t minus delta t. This is delta t into tau raised to the t raised to the power half into dt. So this has to be integrated from delta t to z0 plus delta t. So what we will be getting is expression. So we will be getting finally W2 will be equal to, W2 means is a chord person, WCU will be equal to B k raised to the power 2 is twice r into z0 plus delta t raised to the power half minus delta t raised to the power half into z0 raised to the power n plus n z0 n minus 1 into delta t minus z0 plus delta t raised to the power 3 by 2 minus delta t raised to the power 3 by 2. So this is to be multiplied with z0 n minus 1 by 3. So this will be the final expression for the load which is carried by the curved person. So total weight will be equal to W1 plus WCU. We have expression for WCU. We have expression for W1, which is nothing but B into LT into PGR, B into L1 into PGR plus WCU is this expression PGR. Now we have got expression for L1, that is twice square root of delta t twice r minus delta t. We have expression for Z0, which is nothing but PGR by Kc by L1 plus K5 raised to the power 1 upon n. So this is a series of equations available. So what you have to do is, first you have to assume a value of delta t, which is sinkage, which is the deflection part. Then calculate L1. So assume a value of, assume delta t, calculate L1, then find out W1 and WCU. Then summation of this W1 and WCU should satisfy this condition. If this condition is not satisfied, then you have to change the value of del t till we get a convergence. So this could be an iterative procedure by which we can carry out and find out what is W. Once you know W, then you can find out, knowing the rolling resistance divided by W, that will give you coefficient of rolling resistance. So this way you can find out the rolling resistance, coefficient of rolling resistance for a pneumatic wheel when it is in rigid mode of operation or when it is in elastic mode of operation. So in this lecture, I tried to derive the equation for predicting rolling resistance of a pneumatic wheel, both in rigid mode as well as in flexible mode of operation. In addition, equations are being derived for finding out weight carried by the different section of the wheel. Different section means there will be a flat portion, there will be a curved portion. So what will be the weight which will be carried on the flat person, and what will be the weight which will be carried on the curved person? You can refer to the book like Theory of Ground Vehicles for further enhancing your knowledge. Thank you.